Hey, what's up guys, this is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 127 Random Signals. In this lecturette, I'm going to discuss another statistical inference making technique, and that is hypothesis testing. In my previous lecturette, I introduced you to estimation, which deals with estimating a range of values which we believe with high degree of confidence is going to contain our population parameter, mu, or population, or some other population parameter like such as the population variance as well. But we were focused on population mu there. For hypothesis testing, however, we usually guess what an estimate is, and then we use the hypothesis testing to test whether or not this estimate is a reasonable estimate for the population or not. So let's look into hypothesis testing and formalize what are our general goals with hypothesis testing. So the goal for hypothesis testing is to hypothesize a population parameter and check. So that's the ultimate goal, and check if it is a likely estimate. Now the algorithm to perform hypothesis testing is as follows, and this is going to be a little bit algorithmic in nature. So you'll define something called as a null hypothesis, which is the hypothesis that you're trying to state, and then you'll propose an alternative hypothesis or the opposite of the null hypothesis, and using a particular significance level alpha, you're going to find out whether or not you should go with the null hypothesis or you should be rejecting the null hypothesis. So the first item here is to state the null hypothesis, which is H naught. So whatever hypothesized value that you have for the population parameter, we are going to state here. The second step is to state the opposite of it, state the opposite hypothesis or the alternate hypothesis, which is most commonly referred to as alternate hypothesis. We call it HA, and then we use a significance level alpha, which happens to be the probability of incorrectly rejecting H naught. And we would like this probability to be low. We want to reject the null hypothesis with a very low error probability. So if alpha, for example, if it is like 5%, then there's only 5% chance in my test that I'm going to incorrectly reject the null hypothesis. You want the value of alpha to be very small. Then we use the sample to compute the test statistic and obtain something called as a p-value. Now this p-value is the probability of rejecting H naught incorrectly using this sample. So that's the p-value. So from the test statistic, you will obtain a p-value, which is the probability of incorrectly rejecting H naught. Now you would like for this p-value to be less than alpha, because this alpha acts like a threshold, the maximum error that you can tolerate. If the p-value is less than alpha, then you can essentially safely reject the null hypothesis. But however, if p-value is greater than alpha, then you do not reject the null hypothesis. So these are the 4 steps that are used in order to perform the null hypothesis, in order to perform the hypothesis testing. As an example, consider my sample from spring 2016 random signals final exam. There, the number of students n was equal to 26, so that is the sample size, and the X bar, the mean was 44.77 and standard deviation was 2.87. So let me work on this on the next page. For spring 2016, N was 26, X bar was 44.77 and S was 2.87. In my previous lecturette, I worked with estimation to perform or to identify a range of values which I believe with 95% chance that it is going to contain the population mean mu. In hypothesis testing, I'll be guesstimating my population mean and I'll try to find out whether it's a likely estimate or not. So for example, I say, hey, you know what, 44.77 here seems like a really low value. I don't think that's a proper estimate of the population mean. Instead, I would hypothesize that the population mean actually is 47. Let's say that I had lost a lot of faith in those students and I say that, you know what, the population mean was 47. Now what I'm going to do is I'm going to use the hypothesis testing to find out whether 47 is a good estimate or not. Whether it is a good estimate or not. And then I'm going to do that using hypothesis testing. So the very first step in hypothesis testing, step number 1, is to state your null hypothesis. And the null hypothesis is true mean mu is equal to 47. I believe that if students have SAT score close to 1250, then such students, the average of such students should be close to 47. It should be 47. That's my null hypothesis. The alternate hypothesis is the opposite of null hypothesis, or essentially it's different than your null hypothesis. In this case, my null hypothesis can be, hey, you know what, that's not true. In fact, the true mean is actually less than 47. That's my alternate hypothesis. Step number 2. Step number 3 is to specify the confidence level. I would like to determine a threshold for incorrectly rejecting the null hypothesis. I would like to determine a threshold, or rather set a threshold for the error in rejecting the null hypothesis, and that's usually your parameter alpha. In my case, alpha is 0.05, which means that my threshold is 5%. I can only tolerate 5% error in rejecting H0. So that's the probability of incorrectly rejecting the null hypothesis. I would like for my test statistic to do better than this. If my test statistic using this sample can do better than that, then I can safely assume that null hypothesis is not true. I will reject the null hypothesis and go with the alternate hypothesis. Step 4 is to construct the test statistics. Test statistic. And in this case, the test statistic is obtained as X bar, which is the sample mean, minus mu. This is your hypothesized value, or S over square root of n. So the test statistic here will be X bar, which is 44.77. My hypothesized value is 47, or S is 2.87 divided by square root of 26. So let me really quickly calculate this value and let's see what this value is, what the value of the test statistic is. So negative 2.23 divided by 0.56, giving me negative 3.98. So that's step number 4 to calculate the test statistic. Step 5 is to calculate p-value for this test statistic. Now the t-distribution is usually positive. T-distribution, well, it's always positive. So I'm looking at a significance level at a p-value such that negative 25, comma 1 minus p is approximately equal to 3.98, negative 3.98. So I'm going to refer to my t table and find out what is the value of 1 minus p such that negative t at 25 comma 1 minus p is approximately equal to negative 3.98. So let me consult my t table here. So that's the online t table. I'm looking at the degrees of freedom as 25. I want negative 3.98. So negative 3.98. Well, this is 3.725, and that is 0.0001.0005. This should be p. So 0.005. So actually, you know what? P is certainly less than 0.0005 in this case. This looking up at the table of the t statistic or the t distribution can be a little bit confusing. So I am pretty sure that you may be a little bit confused at how to properly look into the t table, and that's one of the challenges in performing the statistic, and therefore we rely on the R software in order to help us do all of these activities for us. So let's say that I refer to the p table, the t table properly, and I got the probability value as less than 0.0005, which means that the probability of incorrectly rejecting H0 is 0.0005, meaning that even if I were to reject H0, there is 0.0005 chance that I did it incorrectly, which means that I'm in pretty good shape to reject H0. So even if I reject the H0, the probability that I'm incorrect is so small that I can go ahead and practically reject H0 in this case. So I will reject H0. I'll reject H0, and therefore I'll conclude as follows. There is sufficient evidence to suggest that H0 is false, and therefore we'll go with the alternate hypothesis that true mean is in fact less than 47. So these are the step-by-step procedure in which you perform hypothesis testing. You can also perform comparison of two different population, or rather you can also compare two different population means and find out whether there exists a difference between those two population means. For example, what I can do is I can consider the spring 2016 to be a sample from one population. I can consider items from spring 2018 as a sample from other population, and I can hypothesize that the true mean is not different, and my alternate hypothesis will be the true mean is indeed different. I can use the hypothesis testing to perform this test. However, for a handwritten calculation, that's a little bit out of scope in this case. Instead, I would like for you guys to rely on the R software to help you perform hypothesis testing. In my next lecturette, I'm going to show you how to perform all of this statistical inference making using the R software. So it's a good time to stop this lecturette right here.